Welcome to Ready to Derive. In this video, we're going to learn how to factor. What does it mean to factor? It means to rewrite a mathematical expression as a product of two or more factors. Now, I know I've used factor in the definition of factor, but when I say factors, it could be numbers, it could be algebraic expressions. So for example, 6 can be written as the product of 2 and 3. It could also be 1 times 6, but that's an example of what it means to factor. Imagine though we have 2x in front of there, 2x plus 6. Then we will understand that we could write that as the product of 2 and the expression x plus 3. If you apply the distributive property on the right, you'll see how that works out. What's a little harder to see by inspection is how to factor a quadratic expression of this form. That's what this video will be focused on. We are looking for two quantities that multiply out together to give x squared plus 5x plus 6, for example, and that's the focus of this video. So without further ado, let's get started. So before we get into factoring, we're going to just review multiplying binomials using the method we refer to as FOIL. You may not have heard of this, but I'll explain it. I'm sure you have used it even if you don't know the acronym. FOIL stands for first, outer, inner, last. And let's use an example. So the first terms in each of the parentheses would be the x times the x. I'm going to put x squared is first terms. And then the outer terms are the outermost terms. So that would be 5x, so plus 5x, that's the outer terms. The inner terms will be the innermost ones. That's the 3 and the x, so plus 3x, that's innermost. And then the last terms will be 3 times 5, which is 15. And that's the last terms. And the focus here is, okay, so now if we simplify that, notice that the outer and inner terms can be combined to be 8x and plus 15. And this is our final answer, but this method of multiplying will help us sort of check our factoring along the way. So this is a useful technique. So we're going to just practice multiplying these binomials. Notice that the 10 and 8 it's the same in each of them, but I changed up the signs, and this is to help us notice some patterns. So here we go. If we first term's x squared, the outer terms, I'm going to use a little v to indicate outer and inner terms because they're so important. The outer terms 8x and the inner terms give 10x, so I can combine those together to give 18x. And the last terms give 80 when they multiply together. Let's try here. So once again, x squared, we can kind of predict that. This time, because I made 8 negative, it's negative 8x. Oh, and similarly for 10, negative 10x. So that's minus 18x, but it's still plus 80. So we should start to observe, how are these different? Well, we can see that the middle terms, so here we have plus 18, here we have negative 18. And that is because in this case, we had to add 10 and 8, with x, of course, there. And in this case, we actually had negative 10 minus 8. And where else, what other differences do we see? Well, actually, there's no other differences, but it is good to notice that both gave positive 80 as the last term. And that's because 10 times 8 is positive 80, as well as negative 10 times negative 8. So it's really important to start to sort of see the patterns here. Noticing those patterns, I know that the first terms will give x squared, so I'm not going to even indicate that. But what's going to go on here? The outer terms, negative 8x, the inner terms, because they're opposite signs, they will combine to give a different middle term. And the last terms, 10 times negative 8 is negative 80. Notice how I'm starting to take some shortcuts to get to the final answer. So once again, the first term is x squared. The outer terms is 8x this time, and the inner terms negative 10x, minus 2x, and minus 80. So in this case, let's think about, so the middle terms are 2x versus negative 2x, and how did this come about? Well, this is because we had 10 plus negative 8, whereas here we have negative 10 plus 8. And in this last case here, the last term, this again, why we've got negative 80? Well, because one of the terms is positive and the other is negative. So here we have negative 10 times 8. So these observations, we're going to generalize this in the next slide. So to generalize how to factor quadratics of the form x squared plus bx plus c, notice that this only works when the number in front of x squared is 1. The leading coefficient is 1. And we'll learn what to do later when it's not equal to 1, but to start. So what did we observe in the last slide? We observed that whatever the numbers are, we know that when we factor a quadratic, we're going to get the product of two binomials. The question is what number goes in this position and what number goes in this position. I'm going to use geometric symbols because if I use more variables, it just gets a bit convoluted. And we observe that the product of those two quantities will equal the last term c, and the sum of the two quantities will equal b. Now b could be negative as well, but we can take that into account, and c could be negative, but we can adjust accordingly. So what we really need to do to factor is to find two factors of c, the constant term, which add to b, the coefficient of the middle term. So let's look at an example just to make this concrete. So we know that that trinomial or that quadratic should factor as the product of two binomials. And the question is, what are the missing numbers? Now, c is 36. So as mentioned, what we should do is look for factors of 36. And I have kind of a technique here to be systematic about it. Make a little factor table and always start with 1 because 1 will go into any number. So 1 times 36, and then work your way up the numbers. So 2, that goes into 36, it's 18. 3 goes into 36, it's 12. 4 goes in 9. I could keep going. 5 doesn't go in because 5 is not evenly divisible into 36, but 6 and 6. Okay, so I think I've reached the end now. There are no other factors. So now we are looking for the pair of factors that add to the middle term. So let's see, we need them to add to 15, and it seems like this is the lucky pair. So we can put in, if we put in here, we would have, let's put it in red just to make it stand out, x plus 3, x plus 12. We think that's correct. As a quick check, it's always good to check the outer and inner terms. So 12x for the outer terms, 3x for the inner terms, that makes 15x, and we're done. So let's practice using this technique to factor some trinomials. So in this case here, let's see, we know that to get x squared, we need x and x in the first part of each parentheses. And now because there's a minus there, I know that this is going to have to be minus and this is going to have to be minus, and minus times minus will be positive, so not a problem. But let me call up, notice I used 36 so I could call up the factor table we made before. And notice now that they are going to have to be, both terms will have to be negative in order to give a positive 36. And now I have to find the terms that add to negative 13, and here we are. Looks like negative 4 and negative 9. So x minus 4, x minus 9 should work, and you can check the outer and inner terms to make sure that it does. Yes, they add to 13x. Now what if I change this last term to minus 36 instead of positive 36? Well, that means that one of the factors has to be positive and the other has to be negative. Which in particular? So one has to be positive, one has to be negative. To get positive, to add to positive 5x, the larger one will have to be positive in this case. So I'm going to make these negative, acknowledging that they have to make negative 36, and then I look for the pair that add to positive 5. Oh, here's the lucky pair. So x plus 9, it doesn't matter which order, you could write it as x minus 4 times x plus 9. They're both correct. And if you check the outer and inner terms, negative 4x, 9x, that makes 5x. What about this? So still negative 36. So I still want to get negative 36, but now it appears that the larger term has to be negative, and which is the lucky pair that add to negative 35? This would be it. So I can write this as x plus 1 times x minus 36, and I'll leave the checking to you. And then here's the final one. Wow, x squared minus 36. Notice that there is no middle term. But even though it's not written, it's implied that it's 0x. And which pair adds to 0? There it is. And so we can factor this as x plus 6, x minus 6, and we are done. So now we're going to practice factoring slightly different type of quadratic. And notice here that the leading term is not 1 anymore. And why does that make a difference? Well, let's see. We know that to get 2x squared, we're going to need to have 2x in one parentheses and x in the other. And then when we try our technique of looking for two factors of 3 that add to 7, that's impossible. 1 and 3 makes 4. There's no way that we're going to get 7. So that technique doesn't work. And the reason it doesn't work is because of the presence of this 2 in here. It's going to change things up a lot. So what we could do, the thing with the 3, we know that the factors of 3 are 3 and 1, but we just don't know where the 3 and 1 go. Is it the 3 and 1 here or the other way around? It does make a difference. Let's check. If you do the outer terms here, you would get 2x, and the inner terms would give 3x, and that does not add to 7x. So it actually even matters where you place things. So let's try placing the 1 here and the 3 there. Now 2 times 3 is 6x, 1x, and that makes 7x, and that's correct. So for factoring situations like this, where the leading coefficient is not 1, we have to kind of get a little more creative. We can't use our shortcut, unfortunately. Now, what about here? What about in this situation? Because I've got to get minus 12 now. I know with the minus 12, I know that one of them has to be positive and one has to be negative, and I don't know which, and it will make a difference. So what if I did plus 12 and minus 1? Because that's a pair of factors, 12 and 1. So the outer terms would give negative 2x, the inner terms positive 12x. That doesn't work, unfortunately. What about if I switch the 12 and 1? Because that 2 is going to affect things. So if I switch that and I put, like, I don't know, the minus 12 here, plus 1, the outer terms are negative 24. I can tell that I'm way off. That's not going to work. So the problem with this method, or actually lack of method, just trial and error, is that it's going to take a while to land on the correct factors of negative 12, which happen to be, I'll let you know ahead now, negative 3 and plus 4. Let's check that. 2x times 4, that's 8x. Inner terms give minus 3x. That works. But I'm sure you are going to want a better method for tackling these that's more dependable and less based on trial and error. Okay, but first, before we get into the technique, we have to just kind of familiarize ourselves with the idea of factoring out common factors, and you'll see why before too long. So factoring out the greatest common factor from each. So we can see here that this is 4 is the greatest common factor, and you'd be left with 2x minus 3. What about this next expression? What's the common factor? X, and we're left with 2x minus 3. What about here? Okay, this is a little different. Now we have, notice that y is the common factor to both of them, so we can factor out y to get x plus 4. And finally, this is a very important connection to make. Notice that 2x minus 3 is common to both expressions. And think of 2x minus 3 as just being y in the scenario before. So you can factor out 2x minus 3. And what are you left with? Well, you need to get 2x minus 3 times x in one scenario, and then you need to get 2x minus 3 times 4 in the other. So if you think of factoring out 2x minus 3 as a single entity and you're left with x plus 4, does that work? You could check by, if you take 2x minus 3 and distribute to the x, you'd get this expression, and you take 2x minus 3 and distribute it to the 4, and you get this. So now we got to put this all together in a method called factoring by grouping. You may have seen this before, but if not, no worries. It's pretty straightforward. Grouping means you group together the first two terms and the last two terms, and you take out common factors. So as we saw above, this would be x times 2x minus 3, right? That's using this. This here, it would be 4 times 2x minus 3, which is here. Conveniently, I have 2x minus 3 that's a common factor. So I'm going to pull that out as we did up here. Kind of this led to this result. And we get 2x minus 3 times x plus 4. And we have factored by grouping. And we will be using this now in the new technique. We finally get to learn the technique to factor quadratics of the form with ax squared plus bx plus c, where the leading coefficient is not 1. So this is a, this is b, and this is c. I'm going to give you some steps so you can take notes on this to help you repeat the process in the future. You start by finding the product of a and c. So that's 2 times 3, which equals 6. The next step should feel familiar. You find 2 factors of 6 that add to b. So you could make your little table, and it's only 1 and 6 and 2 and 3, but I need them to add to 7. So that would be 1 and 6 that adds to the middle term, 7. The next step is unusual, but very clever. We take our, what was our quadratic, so 2x squared, but in place of the middle term 7x, we write 7x as 1x plus 6x, using that special combination, plus 3. And now you can probably envision what's going to happen next, because we just learned about it. We factor by grouping. So what's common to these two terms? X, and we're left with 2x plus 1. And what's common to these two terms? 3, plus 3. And we're left with 2x plus 1. And you know that you're doing this correct when you have the same expression in both parentheses. And now you can just factor that out as we did in the previous slide, factoring by grouping, and you are left with x plus 3. And you can even check, do your outer and inner terms to check that you've done it correctly. So the outer terms are 6x, the inner terms are 1x, they make 7x. We know that the first and last terms work because we chose them carefully, and we are done. So we'll finish with a couple of practice problems. So the first one is the one we did by trial and error a couple of slides ago. So you'll see how efficiently this method works. So 2 times negative 12, that's a times c, is negative 24. That's step 1. Step 2 is to find 2 factors of negative 24 that add to 5. Now you could make your table. You'll see eventually you won't even need to make the table. You'll just be able to kind of see them, as long as there's not too many of them. But let me just make this. And if we get to negative 3 and 8, that combination works. So there's no need to go any further. And step 3 is to rewrite the middle term as the sum of these two terms. And it doesn't matter what order you do that in, but I'll just do it as negative 3x plus 8x. And don't forget that minus 12. And step 4 is to factor by grouping. So that's x times 2x minus 3. Plus common factor is 4, also 2x minus 3. And then you can factor out 2x minus 3 because it's common to both. And you're left with x plus 4. And I'll leave that for you to FOIL to check that it works. So what about this one here? Well, this, making it a little more tricky, because that 20 times negative 12 is actually a pretty big number, right? Negative 240. So we might want to go about finding factors of negative 240 that's a little more efficient. So negative 240. So you can start with, and I think the bigger one is going to have to be negative. So 1 times negative 240, they're too far apart. They're not going to add that to, we need to get negative 43. So I'm going to skip down here a bit, and maybe, what about 4 and negative 60? They add, oh, that's getting closer. So, but not quite. And what about 5? Does 5 go into negative 240? It does indeed. It goes negative 48 times. So step 3 is to rewrite this as 20x squared plus 5x minus 48x minus 12. And step 4 is to factor by grouping. So what do we have in common here? We have 5x, and we're left with 4x plus 1. Now here, it's when there's when they're both negatives, well, when there's a negative in front of the second of the two, so 48x, it's good to take that negative out, because if you don't, you won't end up with the same thing in parentheses. And now we're at a stage where we can take out 4x plus 1. And we're left with 5x minus 12 in the other factor. And again, I'll leave it up to you to check, but we have successfully FOILed quite a complicated trinomial. So I hope you found this useful. If so, please do like the video and subscribe to my channel. Thank you.